key features of logarithmic functions. Example 1. Graph the function y log base 2 of x. What are the domain, range, x-intercept, and asymptote? What is the end behavior of the graph? So we have here the function y is equal to log 2x. But as we know, the log function are inverse function of exponentials. So because the logs are inverse of the exponentials, we are making here a small comparison with the exponential function. For example, the red function is exponential function. Whatever is a domain in the exponential function, here in the red function, is going to be the codomain, or is going to be the range in the log function. You see here is -2, -1, 0, 1, and 2. And here in the log function is a codomain, or is the range, -2, -1, 0, 1, and 2. So whatever is the range in the exponential function, then is going to be the domain in the log functions. And those points here, if we are wanted to graph, if for example in independent value, we take those values here as are represented in the table, and we get the f of x or y, we get the range, these points here, and then those points we just plot in the graph, and we can graph the exponential, the log function, as is represented here in the graph with the blue graph. So g of x is log base 2 of x. And as we see here, for example, if we are drawing a line that is a y equal with the x, we already see geometrically the exponential function f of x equal to x is going to be symmetric with respect to the y equal with x to the log function g of x log base 2 of x. So now here let's see a little bit of domain. What is domain of this function? Just let me take here a pen. What is the domain? The domain, as we see here, is from 0 to infinity. Is between 0 and infinity. Doesn't matter what small value we are taking, still the graph of the function is going to touch the y-axis here. So here the domain is from 0, so doesn't include the 0, but is between 0 and infinity. This is the domain. And what is the range of the function? The range of the function is from negative infinity to positive infinity. So the range is from negative infinity to positive infinity. So the range of the function. And now we are looking what is the x-intercept. As we see, x-intercept is at this point 1 and 0. So x-intercept is 1 and 0. 1 and 0. So y-intercept doesn't have, because the domain tells us is between 0 and infinity. It's not going to touch the y-axis. And here if we want, for example, this to make more sure and to apply analytically the x-intercepts conditions or the rules, we know f of x has to be 0. F of x has to be 0. And is equal with the log. This is a 0. And 0 is equal with the log of 2x. And as we see here, 2 in exponent 0 is going to be, then for example we are converting in exponential form, is equal with the x, and this implies x is equal with 1. So if and x is equal with 1. So if f of x is a 0, x is equal with 1, and the intercepts in x-axis are 1 and 0, as we have here in this point. Asymptote of the logs. All the logs have a vertical asymptote. So they have a vertical asymptote. And logs do not have horizontal asymptotes. Horizontal asymptotes have exponential functions, but log functions, they do not have horizontal asymptote. So horizontal asymptote is, I will write it does not exist with D, does not exist. I will write with a D and E. So the horizontal asymptote does not exist. And vertical asymptote exists and is a y-axis. So it means x is equal to 0. So the vertical asymptote is x is equal to 0. And horizontal asymptote does not exist. And behavior. If we look in here, as x goes to 0, so it goes to 0, because here is written with a y, g of x. So g of x goes to negative infinity, because goes down, goes to negative infinity. And as x goes to infinity, now we see in here, x goes to infinity, as we see here, as x goes to infinity, g of x goes to positive infinity. So g of x goes to positive infinity. Those are the end behaviors of the g function. Just let me write this is a g. This is a g function. And now, just in the end, let me explain in this graph here. Whenever we have a f of x log base b of x and b is greater than 1, the range of the function starts from minus infinity and go to positive infinity. If f of x log base b of x, when b is between 0 and 1 is greater than 0 and smaller than 1, the range starts from the positive infinity and goes to negative infinity.